So hello everyone. So in this video, I'll discuss the ideal integrator circuit with the op-amp is practical. So I have already discussed the ideal integrator circuit, but at that time the op-amp is considered as ideal. So when this op-amp was ideal, so we have got the transfer function that is V0 upon Vin as minus 1 upon RCS, right? So here the AOL was infinite, so material concept was valid here, but now this is the practical op-amp with a finite open loop gain. It says UL is having a finite value, and which means the virtual ground concept now is not valid here. So which means this inverting terminal voltage is not equals to 0 volt. So it is interesting to find out that what will be the transfer function of this circuit. So whenever this gain of the op-amp is finite, so we have to go with the basics of the output voltage of op-amp, which is defined as V0 is equals to AOL into VD. This is the open loop gain, and this VD is the difference voltage between the non-inverting terminal and inverting terminal. This is the VD. So the non-inverting terminal voltage is 0 volt. So V0 is equals to AOL, and this will be minus of V inverting. So the inverting terminal voltage in terms of V0 on AOL is minus V0 upon AOL. This is we have to find out because when we for the transfer function we have to apply a KCL at this inverting terminal, right? And that's why we need to require this value of inverting terminal in terms of this V0. So now applying a KCL at this inverting terminal, so inverting terminal, so it will be V in minus of V inverting upon R is equals to V inverting minus of V naught upon 1 upon Cs, right? So this will be V in upon R, and this V naught on the left hand side, so V naught into Cs. And now this voltage is common, and this will be 1 upon R, and this is Cs. So taking R in the LCM, so it will be RCS into V naught, and this will be V inverting and 1 plus RCS. Now putting this inverting terminal voltage as minus V naught upon AL, so it will be 1 plus RCS and Vi plus of RCS into V naught. So taking this term in the left hand side and this into the right hand side, so this will be V naught common, and this will be RCS plus 1 upon AL and 1 plus of RCS, and this is minus of V. So this will be V naught and RCS into AOL plus 1 plus of RCS and upon AOL, and this will be equals to minus of Vin. So V naught upon Vin minus AOL upon, now if this RCS, if we take common, so it will be 1 plus RCS and 1 plus AOL. So this is the generalized expression. We can find this transfer function for taking the values also from simple values for this resistor and capacitor and any finite value, but I have derived this generalized result minus UL upon 1 plus RCS and 1 plus UL. So from this we can see that the pole lying at minus 1 upon RT and 1 plus of AOL, right? This is the pole. So the pole zero plot for this transformation will be here the pole minus 1 upon RC and 1 plus of AOL. So this is the pole zero plot for this transformation. So from this pole, we can clearly talk about the time constant. It is simply the reciprocal of the magnitude of the negative real root. So it will be RC and 1 plus UL. So this time constant, it is the generalized result. This is the generalized result of time constant of integrator circuit. This is RC and 1 plus of UL, because as we can see that when this UL will be infinite, right? If this AOL is infinite, so the time constant will be infinite, right? Which we have seen in the ideal integrator circuit. We can say the time constant not exist or not defined. right? This was the case of ideal integrator with the ideal open. And this pole zero plot, what it is representing, which kind of filter it is representing? It is representing a first order low pass filter, this pole zero plot, right? We can see from here also, this is the transformation. So if I put the zero frequency, the magnitude at zero frequency will be simply OL. So this means the low frequency is passing, and at infinite frequency, because the denominator order of denominator is greater than the numerator, so it's simply it will be zero. So the high frequency is not passing and the low frequency is passing. It means it is a low pass filter, right? So this result and this time constant, it is not that much important. This basic style is very should be very clear, because this is the concept of analog. ये बेसिकली जो ये यहाँ सब जो परफॉर्म किया, दिस इज द नेटवर्क थ्योरी. तो बेसिकली नेटवर्क थ्योरी ही है, राइट? KCL and all, and just adjusting the terms, and we have got the transformation. So whenever this AOL is finite, not equals to infinite, so we have to just go with this basic form, that is V naught is equals to AOL into VD, and just substituting these values, find out this transformation. So this is a good concept, that just as the practical integrator circuit behaves as a low pass filter, right? Similarly, we can have the low pass filter from ideal integrator also, but the op-amp should be practical. So ideal integrator plus practical op-amp also behaves as a low pass filter, or we can say ideal integrator with the finite AOL, finite open loop gain, behaves as a low pass filter. So this is a good concept, and this is the general result of the transfer function RC1 plus AOL. So this was the topic. So okay, thank you.